Hi, I'm Cressel Anderson. This is Maker Size. In this video, I'll show you how multi-way switching works. Multi-way switching is used when you want to be able to turn on or off a load, such as lights, from multiple locations. For instance, in my garage, I can turn on and off the lights from over next to the staircase and by the garage door openers. That's what's known as three-way switching in the US. It'd be really convenient if I could switch on the light from the back door instead of having to trip over stuff making my way to the switch. Let's look at the details of how multi-way switching works, and maybe I'll get a switch by the garage door in the not so distant future. In this video, I'll be talking about lighting loads, but the concept is applicable to other types of loads as well. First, let's consider how power makes it from a source to a load in a simple configuration. In simple switching, you have a single switch in line with the load. When the switch is closed, voltage from the source is presented to the load and establishes current flow. This causes the light to illuminate. When the circuit is open, current can't flow from the source to the load and the light is turned off. If we want to perform switching at two locations, however, we need to use three-way switches. Three-way switches are special switches that have three terminals. On the switches I bought, one terminal is a black screw and the other two terminals are gold screws. When the switch is down, the black contact is connected to one gold screw, and when the switch is up, it's connected to the other gold screw. In a three-way circuit, the first switch is connected to the source, the second switch is connected to the load. The two switches are connected together using travelers. These traveling pairs are really the key to multi-way switching. When the first switch is toggled, the top traveler is energized. When the second switch is toggled, the energized traveler or the unenergized traveler is switched on to the source side of the load. Depending on which traveler is connected to the load, it'll either be turned on or off. Either switch can be used to control the load. The addition of one four-way switch gives you another location from which you can switch the load. A four-way switch works by swapping the connections between the pair of terminals. On the switch that I bought, two of the terminals are black and two of the terminals are gold. With the switch in one configuration, the black terminals are tied directly through to the gold terminals. They go straight through. When the switch is toggled, the black terminals are swapped relative to the gold terminals. Such a configuration is helpful because it allows the traveling pairs to be rolled. In multi-way switching, one or more four-way switches are wired between the three-way switches. When the four-way switch is toggled, the traveling pairs downstream from that switch swap energization states. Because at all times one of the traveling pairs is energized, changing the state of any switch in the circuit changes the state of the load. It's possible to add as many four-way switches to a multi-way circuit as you wish. However, it doesn't scale well if you have lots of switch locations or if you want to do something fancy, like switching based on a timer, a motion detector, or some other concept. Using a relay is the most straightforward way to make these applications possible. There are two sets of switches or poles in the relay. Each pole has a common terminal that can be connected to one of the pole's other two contacts. Both poles toggle when the relay coil is energized. Okay, this doesn't look like a four-way switch. A four-way switch is a four-terminal device, but the double pole, double throw contacts have 6 terminals. Well, we can wire up those contacts to function as a four-way switch. We'll jumper together the two outside contacts and the two inside contacts. Then the two outside contacts will be connected to the top traveler downstream from the relay. The two inside contacts will be connected to the bottom traveler downstream from the relay. The common terminals will be connected to the upstream traveling pairs. Now our relay functions just like a four-way switch. All we need to do is energize the coil to get the switch to change states. multi-way switching can be confusing, and it's mainly due to historical wiring practices where a single multi-wire cable might be pulled to the switch location from a light receptacle, or where a neutral wire was not required in all boxes. In older installation, you can run into lots of variation. When I run into confusion associated with multi-way switches, I find it really invaluable to diagram out the switches, the cables, the boxes, and how they need to be connected. I've got a free printable on my website, makersize.com, that hopefully would help you if you run into a confusing situation with multi-way switching. The link is in the description below. I hope this video inspires you to exercise your inner maker. If you like the video, click the like button, subscribe to Makersize, and check out some of our other videos. We'll see you next time. The bulb all the way in.
Actually broke the light.
But you want to be realistic about it. Like, we're gonna come in.
I'll just do my normal
Touch the
little.
wall.
My normal little.
No, don't do that.
This is exactly how I do it. I walk right across.